Dear student, today I am going to take the topic of encoder. So this is the one of the concept from the digital fundamental and computer architecture. So first, what is encoder? So before going to the encoder, encode means one number or any kind of alphabet which will be converted into another form. That means a will be converted into 1. So this is called as a encode. But now here the encode, what is the usage of encoder? Encoder is a kind of digital circuit. So it convert a set of binary input. Binary input is converted into unique binary code. It will be converted into the unique binary code. The binary code represent the position of the input. What is the position? So that will be the binary code. Okay, and also it used to specific input, that is active. So only one input is active. The remaining inputs are inactive state. Okay, so encoder is assign a unique binary code to each possible input. Okay, so only one output is active at any given time, and the remaining output are inactive. So only one output is active, the remaining output is inactive. The active low output is selected based on the binary code assigned to the active input. Then here so the different types of encoders are exist. Priority encoder, so it assign the priority to each input. The binary weighted encoder, which is used the binary weighting system to assign binary code. So it assign the binary weighting system. So already we saw that. So the encoder is a kind of digital circuit. It assign a unique binary code for each input. Okay, so here the digital system convert parallel input into serial. It will convert it parallel input into serial input. Okay, so the encoder is a combinational circuit. What is the meaning of the combinational circuit? Combinational circuit means the circuit consists of a different kind of gates which are combined to form a encoder, which are combined to form a one circuit. That kind of circuit is called as a combinational circuit. So here the encoder is also a kind of a combinational circuit because of two or more gates are combined to form a one circuit. So that's why this is called as a combinational circuit, and also it's a reverse operation of the decoder. So it consists of a 2 power n input line and n output line. Hence it encode the information from 2 power n input. So it get the 2 power n input and convert it into n output. Okay, so then these are the different type of encoder: 4 to 2 encoder, octal to binary encoder, decimal to BCD encoder, priority encoder. Now we are going to see the 4 to 2 encoder. There are 4 inputs are exist in the 4 to 2 encoder and 2 output. Here y3, y2, y1 and y0 is the 4 input, 2 output, a1 and a0 are the 2 output. Okay, so here this is the structure: y3, y2, y1, y0 is the input, a1 and a0 is the 2 output. So here the inputs first, the output is first the what is the output? 0 0 means y1 is active, the remaining output is inactive. Same as here, 0 1 means so only y1 is active, the remaining is the inactive. 1 0 means y2 is active, the remaining are inactive. Same as 1 1 means so y3 is active. Okay, so this is the if it is y3 means we get the result as 1 1. Okay, so this is called as a 4 to 2 encoder. Then this is the formula. What is the formula for a1? a1 equal to y3 because a1 equal to, there are 2 1 So these one represent the y2, these one represent y3. So that's why y3 plus y2, a1 equal to same formula is applied to y3 plus y1. Okay, so this is the combinational circuit which represent the 4 to 2 encoder. Okay, then uh, octal to binary. So the octal number consists of a 8 numbers. So from 0 to 7 numbers. Okay, there are 8 numbers are exist. So that's why the octal to binary encoder consists of 8 input. So the input started from y0 to y7, same as a same as a binary number. Okay, so sorry, octal number. The 3 output is a if you convert the octal number to binary number, 3 digit binary number will be appeared. So that's why 3 output will be represented. Okay, so here these are the 7 input and 3 output, a0, a1 and a2. Okay, so this is the truth table for the 8 to 3 encoder. So if the yeah, if the value here y0 is active, so 0, its value is 0, it will represented 3 triple 0. If it is 1 means here 0 0 1, a0 is activated. 2 means, so it will be represented in the form of 0 1 0. 3 means 0 1 1. 4 means 1 0 0. 5 it will represent as 1 1 0 1. 6, y6 means 1 1 0. So we are first we are taking the what is the digit. 7 means what is the equivalent binary number, triple 1. Okay, so this is called as a octal to binary encoder. Now we take this this three thing, this three now we take the a2. What is the a2 value? y4, y5, y6, y7. So this is a a2, y4, y5, y6, y7. So same as a1 and a0. So this formula is applied. What type of input is activated, that will be added. Then this is the octal to binary encoder. It consists of there are 3 OR gates is exists. That's why here apply the formula as a what is the formula for OR gate? A plus B. So that's why we use the y7 plus is used in between the 2 inputs. Okay, then decimal to binary encoder. The decimal number consists of 0 to 9 digit number. So 0 to 9, there are 10 digits are exist in the decimal number. The BCD is a 4 digit number, so that there are 10 input line and 4 output line. Okay, so here this is the 0 to 9, there are 10 inputs, the 4 outputs are available. Okay, so same as the previous one. If the y0 means 0, so it will be represented as a unique binary code 000. 1 means 001. So like its number, y3 means 011. So 9 means y9 means, so equivalent binary number is for 9 101. So this is the one of the example. So now we take the a3. What is the a3 value? So it consists of y8 and y9. So that's why what is the a3 value? y9 and y8 plus y9. So likewise we are calculate a0, a1 and a2. Okay, this is the circuit for the decimal to BCD encoder. Okay, so dear student, now you see the video of the encoder and its type. If you have any doubt, please kindly give the question clearly in the comment section. I will clear your doubt. Thank you, student.